Okay, so the next thing we're going to do is start to write a script which will take this feature and target data and actually train a classification supervised machine learning model to understand and predict other comments. I'm going to start a new script, and I'm going to save as and call it O3 train model. Okay, so again, I'm just breaking up my process into a few different scripts that do specific things. As always, I will specify my working directory, and then I'm going to import a few libraries. First, of course, I need the pickle library to bring back my data sets, and then I'm going to import a few libraries from the scikit-learn library. Okay, and these are the specific things I'm going to use to train the model. So I need the pre-processing library to normalize my data set. I need the SVM library. This contains the actual model I'm going to use. And I'm going to import a plotting library. This is pyplot. And this will, I'm going to use this to plot some of the data so we can see what the data actually looks like before we train our algorithm. Okay, so these are just two imports to be able to plot our data. And then I'm going to import NumPy. Remember, this is the kind of numerical processing library that scikit-learn uses to do its computation. And then I'm going to import the random library. And as before, I'm going to set my seed so I have reproducible results. First thing I need to do is bring back my two data sets that contain all the training data. So I'm going to go back here, just copy and paste this code, and then change it to have it actually load up the files. Okay, so make sure your code looks just like that. And the next thing I'm going to want to do is break up my data set into a training set, which will contain 70% of the data that will actually train the model, and a validation set that we'll use to actually check the performance of each model and decide on the best model we're going to use. Okay, so one issue right now is that our features and target data set contain two big sets of data, one for inside OCT and one for outside. And when we create our training and validation set, we don't want to just cut a certain portion of the data set as it is now, right? We want to randomly sample. We don't want to just choose all of the OCT data for training and then all of the other stuff for validation. Okay, so we want to shuffle this data as well. The problem right now is if we apply a random shuffle to these data sets separately, they're going to lose connection to each other, okay? Because the random shuffle does it randomly and it's going to do it both times, and then they're going to become disassociated, the features and the target. So what I'm going to do is use some NumPy code to actually first zip together these two data sets. This will combine the features and target into one multi-dimensional array. Then I'm going to actually shuffle that big data set. So this has both the feature and target still connected. Those get randomly shuffled. And then I'm going to extract back out the features and the target data into two separate data sets using this code. This is kind of NumPy code used to work with arrays. You don't really have to know this. You can always Google the specific thing you want to do. For instance, in this case, it's shuffling two data sets while maintaining the connection, and you'll usually find this kind of code to use. Okay, so then I want to cast my features and target data, which right now is still in the Python array format. I want to cast that to NumPy arrays so we can start to work with it in the scikit-learn. So I'm going to convert my features data set into the big X array. Remember, this is standard kind of machine learning nomenclature. And then I'm going to cast my target data set into the and the small y target array. Okay, now I'm going to create a variable which will specify where in my list the 70% mark is. So I'm going to ask it for the length of my target. This will just specify how many data points I have. In this case I have 8,000, but I want this to be able to scale. And I'm going to multiply that by 0.7. Okay, so depending on my data set, it's going to tell me where is that breakpoint for me to take the first 70% of the data. And then I'll just set up my training and validation sets on my data. So xtrain is going to take from the all the data up to that number. And then my x validation set is going to take from the x data set, starting at that number all the way to the end. And now I'm going to do the same thing for the y. Just going to copy and paste here. Replace those variables. Okay, so now I have a x and y training set and an x and y validation set. I can start to train my machine learning model.